Hello everybody. To further continue, we are going to see the diagnostics in thermal management system. Thermal management system is an important part of the EV, and we are going to see the role of diagnostics in thermal management system. Now, diagnostics in thermal management system of electric vehicle is critical for ensuring safety, reliability and performance of temperature sensitive subsystems like battery, power electronics, motor and cabin. Now these are all the subdivisions of thermal management systems, and their safety and reliability is of extreme importance for efficient working of an electrical vehicle. And because components operate efficiently only within a narrow thermal window, early detection and resolution of faults in TMS is vital to prevent failures, enable derating, or trigger emergency shutdowns when necessary. Now, when it comes to thermal management system, what is this thermal management system overview? Electric vehicle thermal management system is a multi-loop system integrating. First thing is battery thermal management. Second is power electronics cooling, inverter, OBC, DC-DC. Next is motor cooling, cabin HVAC system for passenger comfort and heat pump operation. It includes liquid cooling circuits, coolant pumps, valves, heat exchangers, fans, and sensors. Also compressors and controllers, which is dedicated to DTMS thermal management system ECU, or integrated into vehicle control unit or battery management system. So what are the main objectives of this diagnostics? What are the main diagnostic objectives? First is safety, that is to prevent the overheating, thermal runaway or freezing. I'm sure everybody would have seen in some WhatsApp forward or Facebook forward that vehicle is catching fire all by itself. That is called thermal runaway. That is the output of thermal runaway. So to prevent the thermal runaway and to maintain the safety of the vehicle is the important goal of this thermal management system. Second is longevity, to ensure thermal cycling and exposure are within the design limits. Next is efficiency, detect the stuck valves, failed pumps affecting the energy consumption. Next is compliance, align with ISO 26262 for asset related subsystems, battery and motor. And when it comes to serviceability, log DTCs and fault codes to support maintenance and repair. All right, so these are all the various types of diagnostic goals that need to be that need to be fulfilled. Now, when it comes to diagnostic domains in thermal management, we are going to see the various diagnostic verticals in thermal management. First is temperature sensor diagnostics. Okay, when it comes to temperature sensor, first is out of the range detection. Sensor reading outside expected minimum max, for example, less than minus 40 degrees and greater than 150 degrees. So within minus 40 to 150 degrees, it is supposed to work in an efficient manner. Now, when it comes to plausibility checks, cross compare redundant or nearby sensors. Example, battery inlet versus outlet. And when it comes to stuck sensor detection, no change in value over the time. Okay, this is called stuck sensor detection. There is absolutely no change in the value over the time. Now, when it comes to open and short detection, resistance based fault detection thermistors. All right. So, for example, battery cell temperature sensors, inverter coolant temperature sensor, HVAC evaporator sensor. These are all the various kinds of sensors that fall under the category of this thermal temperature sensor diagnostics. Your, Now, when it comes to coolant loop diagnostics, first is coolant loop monitoring. When it comes to coolant pump monitoring, you have to detect the electric fault, you have to detect the speed mismatch, you have to ensure that there is no coolant flow or inappropriate coolant flow via flow or temperature delta sensors. Okay, and last is air lock detection. You also have to ensure that based on the noise and flow consistency, there is no air lock. That also has to be monitored. Now, when it comes to coolant flow sensor diagnostics, stuck reading or signal drift, sensor range errors. And when it comes to C, coolant temperature gradient check. And next is difference between inlet and outlet temperatures, detects how flow blockages or ineffective circulation. So these are the various types of monitoring, and these are all the various aspects that need to be monitored or that fall under the purview of coolant loop diagnostics. Now, when it comes to thermal valve diagnostic, first is the actual health monitoring, whether the position mismatch needs to be monitored very thoroughly. Okay, the command versus feedback, whether it is working properly or not, must be, I emphasize the word, must be thoroughly monitored. And next is jammed or stuck valve, detected by no change in downstream temperatures. Now, when it comes short open circuit in motor driver, valves are used to switch coolant between battery and motor loops. Bypass or direct flow to exchange heat exchangers. Okay, bypass or cool direct flow to heat exchangers. Now, fan and heat exchanger diagnostics, fan motor fault. Okay, first you have to take care of the fan motor fault, current voltage monitoring, speed sensor feedback. With the help of the voltage monitoring and speed sensor feedback, the fan motor faults are thoroughly monitored. Now, when it comes to cooling capacity monitoring, you have to take care of this parameter. Ambient versus heat exchanger outlet temperature is a very important parameter that has to be kept under visual. Next is poor cooling indicates blockage or fan fault. All right. So to proceed further, when it comes to HVAC and refrigeration circuit diagnostics, in systems with heat pump or HVAC refrigeration loop, first big component or first big system that comes under diagnostics is compressor. So within compressor, electric faults like starter short, locked rotor may occur. And when it comes to discharge pressure, temperature between the threshold holes. Now, coming to the pressure sensor diagnostics, implausible readings mismatch with ambient and expected value. Okay, next and within HVAC, important vertical is division is refrigerant flow control valve. All right. So within the flow control valve, there may be an actuation failure, there may be improper heating and cooling cycles, and also the degradation monitoring. Now, when it comes to degradation monitoring, reduced cooling, heating efficiency over time. Okay. Now, when it comes to battery thermal management specific diagnostics. Now, when it comes to battery thermal management specific diagnostics, first is heater diagnostics. All right. Uh, there may be a chance that no response to heat command. There may be over current or short detection. Now, when it comes to chiller efficiency degradation, inadequate battery cooling during fast charging. Okay, this is one major error that can happen during the chiller efficiency degradation. Okay, now when it comes to cold soak detection, it triggers battery preconditioning if required, and thermal runaway risk, rapid temperature rise in adjacent cells. Okay, so these are all the various sub areas or subtopics that must be clearly covered during the battery thermal management specific diagnostics. So when it comes to system level control and logic diagnostics, thermal mode arbitration faults, conflict in thermal parity, example cabin versus battery cooling, and when it comes to improper state transitions, system stuck in heat mode, bypass to cooling mode, and unstoppable control loop. Now, when it comes to unstable control loop, oscillating temperature control or unstable set points. Okay, so these are the three areas that come under the purview of system level control and logic diagnostics. So let's see some diagnostic trouble codes as far as this thermal system is concerned. For example, P0C73 talks about inverter coolant temperature sensor fault. P0AA6 isolation fault may be caused by coolant leak, and P1C74 battery chiller temperature difference too low, and P1C75 power overcurrent or open circuit. Next is B10A7 and HVAC compressor signal error. And when it comes to P1A3F, battery thermal runway risk detected. Okay, so these are the various types of diagnostic trouble codes that can pop up during the monitoring of this thermal system. Now, what are the various types of diagnostic execution method? How are you exactly going to execute this diagnostics? First is startup self method. It validates pump, sensor, and valve readiness on ignition. Now, next is continuous monitoring, runs at regular intervals or on thermal events. Next is event-based triggering. It starts on charging, fast charging, or extreme ambient conditions. All right. Now, this is very commonly used diagnostic execution method. And coming to the redundancy check, it validates one sensor using another. Next is last but not the least, field testing or hardware in loop testing. It validates diagnostics through fault injection scenarios. Now, coming to the functional safety and cyber security. In the functional safety and cyber security, the governing standard is ISO 26262, and for this thermal system usually is ASIL B or ASIL C for the thermal control of battery or motor. Now coming to the heater over pump, failed pump, valve malfunction can cause safety violations. Now coming to secure diagnostics, only authorized tools can run UDS tests, which comes under the purview of ISO 14229. Cryptographic protection in software updates to TMS. And what are the various tools? Tools are Vector Cano, Canalizer, ETA Synca DSpace Control Desk for sensor calibration, and HAL Bench by National Instruments or AVL for simulation of temperature, flow, and actuation faults. OBD2 scan tools, which means TTC readout and actuator testing, thermal imaging and sensor fusion, lab level advanced diagnostics. So these are the various kinds of tools that are used in thermal diagnostics. Now, when it comes to summary, to finally summarize, these are all sensors, pumps and fans, valves, refrigeration system, thermal performance, system logic. These are the various areas that fall under the diagnostic categories. Okay, key faults like open short and out of the range, electric failure, actuation failure, stuck jammed, compressor pressure sensor, cooling inefficiency, overheating, mode transition faults, arbitration errors, all are under this key faults detected. Okay, so hope all of you got the various types of diagnostics used in thermal systems. Thank you.